You're awesome. Well, hello, everyone. My name is Alex Antonison, and thank you for coming to Nashville Data Nerds. Calling it Nashville Data Nerds for one person. Hi. As I said, my name is Alex Antonison. I'm the organizer of Data Nerds. With us tonight is Kevin Brendel. He is a data engineer that I've worked with previously, building a lot of scalable data applications using languages like Python and Go, and recently Scala. And he is here to talk with us tonight about developing, Scala, developing Spark applications, in a safe way with Scala. Real quick, the sponsor is my consulting group. I sponsored the meetup myself. We're a consulting company that provide solutions that, foster growth through efficiency for our clients. Two organizations I always like to call out is Nashville Software School. They're a great organization if you're looking to level up in tech, whether it's software development, data analytics, or data science. And there's there's a community called Penny University that I'm a huge fan of if you're looking to kind of tap into data and just have people that you can bounce ideas off of and have conversations around. And it's not just limited to data. It covers software development, investments, raising kids, all those sorts of conversations happen there. So if you're interested in that, feel free to check that out. And then real quick, just how this format goes. As you all know, over Zoom, it's challenging to have multiple people talking at once. So even though Data Nerds ideally is a conversation, the way I run it is I moderate questions. So if you want to post questions into the chat, I'll keep an eye on the chat. When there's a logical break in the meetup, as Kevin's speaking, I'll pose the questions. And then the last 15 minutes will be for kind of that open discussion. But without further ado, all right, Kevin, the floor is yours.
Yeah, 2 years in and I'm still muted. I'm trying to talk. Hey, I'm Kevin Brendel. I'm just gonna pull up the screen. So yeah, I work with Alex a bit, and I do a lot of data related stuff. Full disclosure, Scala is definitely newer in my programming build. So I'm by no means an expert, but learned a lot about it, and have been really enjoying it over the last months that I've been using it. Even though coming into it, I was definitely not one who would suggest the JVM, but definitely using it recently has kind of changed my mind on some of that. So a little bit about me. I'm a senior data engineer at Lark Health. So at Lark, we build a mobile app for health tech. So we do a lot of sensor related data and getting data from different health plans. So I work on that data team, building out our platform, aggregating our data so that we can do reporting, so that we can analyze other data, do all sorts of stuff. I'm based in Atlanta, Georgia currently. I do love dogs. This is a picture of my dog, Capone. And yeah, overall, I got into analytics out of college with a degree in statistics, started doing machine learning. And in that time, I got pretty quickly in my career into like doing big data, Spark stuff. And I kind of transitioned more to like software and then into the cloud, but still all revolving around data, how we can process it, how we can use it. So today, I kind of want to go over a few things, but I don't want to get too into the weeds, because if you've messed with functional programming, it can kind of get out of hand pretty quickly. So not going to go too deep, but we're going to focus on being able to use it. So really quick, just want to brush over some differences in languages so that we can talk about strengths and weaknesses, get a very basic understanding of the benefits of functional, talk about structuring a functional Spark application, and then we'll go through some code. And everything we're doing today, I will post in our meetup right after. So that'll be the slides. I'll put the link to GitHub, so don't feel like you need to write anything down. So as you all are aware, most likely, right? There's like a bunch of different ways that we can divvy up different programming languages. One of those is like interpreted versus compiled languages. right? So we're talking about Scala today. So Scala is a compiled language, which means we get a lot of safety. So before we ever run our code, our compiler is going to check it out, make sure it all works, which usually means we get some runtime performance compared to interpretation. And there's a lot of other pros and cons. But yeah, the big one that kind of focuses on here today are trying to reduce some of those runtime bugs because everything's statically typed, right? Every function has the same input and it's guaranteed. And those are some of the really big ones that are going to be helpful for us. It can make things more challenging, right? Since all your data types are guaranteed, if you change one, that can cascade. So there's cons to everything. But, yeah. Okay, so yeah, I don't want to go too deep into all this because I'm sure you all know, and it's probably just a review. And I obviously left a lot out of here. So if you see things that are missing, there definitely are. Did I skip? Oh no. So yeah, people want to complain about inefficient programming languages. Yeah, anything other than assembly is definitely slow, but it's all relative, right? So runtime isn't everything is usually the most important thing to keep into perspective, especially as compute gets cheaper and cheaper. So along with kind of like compiled and interpreted languages, right, we also have dynamic and static typing, which a lot of times they like group together, right? But you can kind of get around with them. And particularly like I added Python under both sides because we use tools to give us statically typed code through static analysis. So, right, again, static typing is going to help us with a lot of data type guarantees. Hopefully make things a lot more predictable. Again, you're going to get more performance, usually in a language that's made to be static because you don't have to carry around types and do type checking all the time. But again, change something, it can cascade again. Dynamic languages are usually super nice to use, right? Because you can kind of mess around with them. You can reassign variables all over the place. Well, I guess that's different, but anyway, right? We get a lot of safety when we go towards static, and you see that more and more with like a lot of people going towards declarative models for anything. Like Kubernetes is like always a big one that I like to go to. Like everything in Kubernetes is declarative. Like you define what it should be, and then it makes it so, which is very nice. So if we can get there in data, that'd be sweet, but that would probably be very difficult. So functional programming. This is like a very, very basic overview. And I pretty much purposely left out a lot of the nuts and bolts because I wanted to just keep this at the high level of kind of what are going to be the things that it can do for us. And there's a lot of really good resources out there that you can learn from that I would not be good to recreate. So I'll leave those other resources up to the more seasoned people. But I took the definition off of Wikipedia here. It says it's a programming paradigm where programs are constructed by applying and composing functions. So it's all based on lambda calculus. So if we can break things down in the right way, we should be able to, move them around, swap them in and out, and things should still work the same. And that concept is something that you'll hear a lot when you look into functional, and can be really useful when you get into like refactoring your code and needing to reshuffle things around. As far as the benefits are concerned, one topic you'll hear a lot, and I'll probably say a few times today, is like talking about purely functional code. And in this concept, pure functional code is completely error-free. We do know that that's not really realistic. So I'll say realistic functional code makes a possibility of errors explicit and encapsulates things to tell you that they can fail. And we'll see exactly what that means, but basically we'll do a little bit more annotation of our code to say, hey, this can throw an error. or hey, this requires some external dependency. And that helps us like really capture the things that will fail, the things that are on the edge. Because anything we can do, right, we can add, we can add some numbers, we can run some little algorithms inside of our code, and we can test it and we can know it works exactly every time. And it's usually the things on the edge that are going to fail. So one of the things that we'll do in functional is kind of wrap those up so that we can kind of like deal with those things on both ends, on the bookends, and then everything in the middle is more guaranteed. Another benefit, I would say testing is a little bit easier to be more complete. And this is kind of because of what I was just talking about, right? When you split out those things at the edge, you're already separating like an interface into your program. So instead of hooking directly into a website API or something, it kind of like forces you to create an intermediary layer, which then makes it really easy to mock those things. And that's something that we'll show today. And it's something that like we do all the time at Lark for all of our like data testing. And it makes it pretty easy to work with. Another one, our components generally can be swapped more simply. And that just goes back to the foundations of functional. I can tell you that I can't solve everything perfectly because I'm still like on my journey of learning this, right? So there's a degree of figuring things out because you kind of need to think a little bit differently. It kind of forces you to do that. One of the biggest ones, benefit will be immutability. It's not always possible in some cases, right? But most of the time we should be aiming to use immutable variables, which eliminates all sort of like overwrite and object mutation bugs. So just like Rust tries to do with a whole class of, nil pointer dereferences and garbage cleaning errors, right? If we use the immutable variables, we just eliminated a whole class of bugs that we don't even have to worry about and won't impact our program. And finally, one of the interesting benefits that maybe we don't notice a whole lot, but is pretty neat, is lazy evaluation. So Spark does this all the time. And even if you get into like Haskell, they do it a lot. And there's some really cool stuff you can do with that. One of those being, right, you can kind of like figure some stuff out before you actually run all your code. So you can kind of like get further through your program with less execution in some cases and catch your bug. Or other times, right, you can use infinite lists because you kind of declare what it is without having to create the whole thing. So you can step through it infinitely because you're lazily evaluating every index of your infinite list. Just like anything else, we'll say there are some drawbacks, right? It is a little bit weird to get started on. So it does require you to think a little bit differently. Anytime you're declaring a bunch of variables, right, you have to keep track of them, clean them up, they take space. So there's a little bit of performance hit that you're going to take, of course. Another interesting facet with functional programming is we pretty much don't use for loops, and everything is recursive. And because of that, it's susceptible to Stack Overflow without properly reviewing or having static analysis in place to be able to understand that, hey, you have a path that does not end. So, definitely some dangerous points there if you're not careful. And we'll kind of like break there. I think I saw something come through in the chat.
So with Ed, recursion, when working with big data, have you found situations where tail recursion was not possible?
I don't know how I'd be able to answer it, just because, right, finding something that's not possible is going to be very difficult. And I probably don't explicitly call out tail recursion. And it's most of the time, it's like, I've been working with this maybe for, 6 months. So I haven't really gotten towards needing to get crazy performance, and largely because I'm using Spark. And I'm a lot of times taking advantage of the optimizations that they built into that program. So like tail recursion specifically, right, is largely just optimization. So that's actually one that I haven't gotten too deep into. And honestly, yeah, Spark has done a really good job of doing a ton of optimizations on their workflows since it's built in Scala. And they needed to do that in order to scale. So good question. And I'm actually curious about that myself. So maybe we'll be able to figure that out at the end. So yeah, everyone's talking about OOP versus functional. I'm just sitting over here bashing out SQL. Been there before. And it's how so many companies work, because it does allow you to move a lot faster in the beginning. But like anybody who's here has done that, right? You probably going to be a point where you miss a parenthesis or a comma, and your SQL scripts start to degrade over time. And of course, you limited to SQL, right? So you need to handle all of your optimizations there. And especially as you get transpiling into different SQL dialects. Yeah. SQL is great for doing really interactive stuff, but as a long-term and like largely distributed application, it's a little susceptible to a lot of issues just in growing. So yeah, we're all here kind of to talk about Spark today. So I'm, assume a lot of you have heard about it, but in short, it's pretty much the standard for big data processing. A lot of stuff for doing SQL, so everything database kind of related transformations. Plus, they have machine learning, streaming, and graph computation stuff. So a lot of great packages out there to do some really powerful work, all based on a distributed MapReduce paradigm in Scala, with APIs for Scala, Java, Python, and R. So, they cover all the major languages that people use analytics for, except for, I guess, like Julia, up and coming. But Python and R are definitely big ones, and Scala, Java. So, you can always use those here. You won't have all the same stuff that we're going to talk about today, but even in Python and R, you can still do really great stuff. There is just that transpilation that needs to happen to port it over to Java in the backend. So yeah, and right internally, the data is going to be represented as an RDD. So originally, when Spark came out, it was pretty much the RDD was the way to do things, and that's that resilient distributed data set. Eventually, they created the data frame API, and then shortly thereafter, they released the data set API. And these are all different ways to, interact with the data frame, with the tabular data set. So we'll be focusing on the data set API today, because that is the strongly typed version of a data frame. So if you've worked with like Python in Spark, you've always used data frames. It very much feels like a pandas data frame in a lot of aspects. The data set takes that one step further and just puts a little bit more type specific stuff on it, so that you can do joins a little bit differently. You can apply functions in Scala directly against it. So you can write like native Scala code and apply it row-wise, or group-wise, I guess. But it just gives you a little bit more type safety on top of that data frame. And kind of like I alluded to earlier, when we get into creating like a functional program, right, we want to be able to use like pure functional as much as we can. And kind of like in order to do that, as much as we can, we'll try to aim for this pattern of right? Let's read in our data. So do all the things in the beginning that we need to load up with our external dependencies, right? So whether we're reading against a database or S3 or something, we'll handle those external interactions. Then we'll kind of shift and transition into just our pure functional transformations and get all of our data into the state that we want. And then at the end, we'll try to do again, write out our results or send them somewhere, do whatever we need to do externally again, so that we can kind of like limit the points in our code at which we do those external interactions so that we have like stronger guarantees of it kind of working. And I swear I'm like almost done. Slides are boring. I know that. So the last thing I want to touch on here is Zio. And Zio is just a library in Scala for working functionally. So they provide like a whole framework that does all sorts of stuff. One of those things we've been talking about, or I've mentioned, is we kind of had like a middleman on top of any of our external calls. And in Zio, they refer to those as layers. So just like if you're building a piece of software and you wanted to do dependency injection, you can do the same concept using layers in Zio, where you have, an external something that has some certain functions that you need to use to interact, and you make that available through the use of these layers. It also defines type signatures, and these type signatures go further than just telling you data type, but specifically we use them in like function returns. So it'll tell you the data type, but also tell you which of those layers or dependencies are needed for that specific function, which tells you if it's interacting with the outside world. And it'll also tell you if there's an error that can be thrown or what type of error can be returned. So those type signatures are really like useful when we get into functional, because they do two really important things to tell you, can it return an error and does it need a dependency? And if it doesn't need either of those, that's when it's pure. And we can guarantee that it will never fail unless the whole machine dies. Another piece that Zio actually does specifically is it's also like a scheduling engine. So it handles concurrency with better than Java green threads. So just a kind of useful feature there, but nothing too crazy. And overall, yeah, it makes it testable. And they have even some libraries to do a lot of neat stuff that I haven't gotten totally into yet. But yeah, there's a couple different ways that people do this. Zio is definitely one of the very popular ones in Scala for doing this type of stuff.
Real quick, we have another question from Ed. Have you come across big wins using data sets versus data frames?
Yeah, for sure. And actually, that's kind of one of the last things I want to get into. Yeah. So basically, when I worked with Alex, we did a lot of data set stuff or data frame stuff. We did Python and PySpark, just like many people do. And we did everything with data frames. Kind of like I'd say the downside of data frames is like, when you think about SQL, right, you have your script and it's doing like select fields from your tables and you join it. And it's basically a big text block. And I say the thing that makes it kind of fragile is that it is just a big text block. So, if you've written Python, white space can kill you. And that can go for SQL too, right? A parenthesis, a quote, any of these little thing can make like huge problems and just cause it to fail. And that can kind of happen with the data frame API, because as much as it like we get into Spark and you refer to data frame, it's a lot of still selecting text strings. And those text strings get converted in the back end into Java that get converted back into the other object. So there's like not a whole lot of parity between the backend object and your code layer. The dataset API improves on that by allowing us to define structures and use those structures to refer to the code. And we'll jump into a little bit more of that. So basically we can define a class. And I can say, this data frame is a bunch of rows of this class. And, I can refer to those class members to call the columns. So they're always guaranteed to be there. We can even define, class methods and use functions across rows more easily. So yeah, we've definitely found a lot of use in data sets and huge productivity gains and a huge reduce in errors. So yeah, one of the best things about doing some of this stuff too is if you've worked with compiled code, you've been here where you compile error, compile error, compile error. And they do it too, especially in Spark Scala, working with like all sorts of this typed code. And what's great about using Scala with Spark is it is the same language that the program's written in. So we get direct access to everything we need. So we can do really good unit testing really easily. And I'll show you some of that, and we'll have some of that code. So yeah, last little bit here. Why? This is based on my using it for a little while, and also speaking with others that have been using it longer and doing more research. So yeah, using this functional Scala for Spark provides us with the compiler help, so we can gain a lot of confidence in our code before we even click a button to run it. Which, if you've run like AWS EMR or Glue, right, that can save you so much time and money just to know that, hey, my code at least comes together. Whether or not it works or not, well, there's still a little bit there, but it comes together, so it has a good chance. All right, and like I just said, since we're using that program, the language of the program, we interact more natively and can get to use more features. So if you've used like PySpark, hopefully you've used cryo serialization, because that'll speed up your programs a ton. And that's just because, right, we need to convert Python objects into Scala objects. When we're working in Scala, we don't have to do any of that. So there's no transpilation required. So we gain some efficiency there. Yeah, our interaction with Spark becomes seamless, which also allows us to do interactive testing and debugging like very easily. And we can do some of that today. And then overall, I found it to make me a whole lot more efficient in building data processing software. Okay, so that's kind of it for the boring stuff. And I think
one question we have is, how do you feel about optimization of Spark jobs, and what do you think will help the most in optimizing long-running Scala / PySpark jobs and reducing runtimes of the jobs?
Yeah, so right, how do I feel about optimization? I mean, I'm going to say this definitely depends on your use case, right? There is generally a lot you can do with Spark, right? The biggest optimization you can do is cut the program down. You want to take advantage of executors as much as you can, because that's like your lowest level of parallelization. So yeah, the more you can work in smaller chunks, right, the better off you're going to be. And optimizing long running jobs. Yeah, I mean, it kind of comes back to the same, right? The biggest, I mean, you're going to need to jump into the Spark execution, like the DAG execution, and see like what's causing that bottleneck. And the Spark UI can do a good job of that. And if you're also using other tools like, I know Data Mechanics, they created a different version of the Spark UI. It's actually a little bit nicer to use, and it can more easily show you some of those bottlenecks. So like a lot of them usually come from just broadcasting data around the cluster. So whenever you try to do those big joins, those are going to cause some issues. But yeah, it's hard to say without knowing exactly what the issue is. So you're definitely going to want to jump into that Spark UI or at least understand where in your code is taking long and figure that out, because it's right. A lot of times it's a big join somewhere. And it looks like Ed had one more question. We're using
Do
Apache
you have a
Spark.
demo that you wanted to show us? Because I'm thinking I was actually just about to post in the chat. We can take further questions and post and like kind of tack those on the end. But want everyone in the time frame. Let's go for us to go through that demo real quick.
Sure. Yeah, we can do that. We can come back to that. Yeah, we can definitely talk about tools. Okay, so sorry, just moving a window around a little bit. So this is kind of the project that I'll be sharing out later today. We're not going to do anything too crazy here, but we are going to query a Postgres database. We're going to query it live, and we're going to query it in unit testing. And we're just going to do some transformations on that to do a little bit of filtering, mapping, joining, a couple of things that you'll probably use like very regularly to give a good basic foundation. So based on our pseudocode, we kind of followed. This is kind of going to follow that pattern we talked about. We're going to do some interaction with the outside world. We're going to do some pure transformations. Then we're going to interact again. So yeah, this is going to look pretty crazy off the bat, I'm sure. So I might not go into everything just because it'll very quickly get down some tangents. But so one important thing is right here. And I mentioned earlier that Zio allows us to define our dependencies, our error potential, and our output. And that's what we're going to do here. So the first one, we're saying that this function needs access to a console. And that's just like right into the console because I want to do some printing. It has access to a service I created, which is my configuration. And it has access to a Spark service, which allows us to interact with the Spark cluster. That's basically, these are our external dependencies. So the only thing that our code is going to interact with outside of itself or outside of like Scala, pure Scala code are those few things. We're saying that this is throwable, so an error can be thrown from within this function. And then it's going to return a unit, which if you haven't done Scala is just nothing, void or no return. So yeah, the first thing I do here, this is going to be dependent upon our Spark service, and we're just going to load in Spark so that we have a Spark context available. And we'll jump into like how that becomes. And kind of the next thing, I define an environment with this config. So it's going to base itself off environment variables and load some information in. You can do the same thing with command line arguments or environment variables, or even like read a text file or something if you wanted to. Either way, you probably need some type of external configuration to give you a little bit of information on what to do. In this case, it's very basic because I'm not doing a whole lot here, but it has the application name. And then this again is just using this. This is actually like right into the console. You'll see it's like Zio console. And that's only because we have like this part here. So another one of those things about compiled languages, you usually get pretty good IDE help. So yeah, when I remove console, it like freaks out. It's like, wait, you can't call this function put string line because you don't even have access to a console to write. So like right off the bat, that's just, I just wanted to demonstrate some of how that static analysis is going to help us a lot. And that's the safety of like not even the code itself, but really helping us ensure we know and we understand when our code's communicating outside of like just Scala. So it really helps you just like keep track of where things can fail to help reduce chances for bugs. Okay. So yeah, again, in this case, we have our Spark service, which I defined, and I'll show you here in a bit. And this is going to like read from a database. So I just created this read database function as our Spark layer. I defined a class essentially of what the objects are, which each row in that database is. And it's just going to fetch that. And this is running in Docker. So, nothing too fancy here. And you could, of course, make these functions a little bit nicer to not repeat them so much, but this was purely for demo purposes. So yeah, did a pretty simple function to get some data out and run that a few times. And now we kind of get to the point where we have all of our dependencies to do our analysis. And then basically we're just going to go line by line, and we're going to do some steps of transformation. So the first thing we're going to do here is we're going to filter these films. And sorry, let me take a step back. The data set I'm using here will be listed in the README to download it. It's called like Pagula. It's like a standard Postgres test data set. It's all about like, it's like a blockbuster type deal. So there's movies and actors and rental stuff. And basically what we're going to do here is we're going to find all of the movies that are 90 minutes or longer, and count all the movies that the actors have worked in, that are 90 minutes or more. So we're at the end of this, we'll get a nice list of actor names and how many movies they've acted in that are at least 90 minutes. So the first thing we're going to do is we're going to filter out films. Then we're going to join films and actors. And then we're going to calculate that film count. And basically what we'll end up finding here is everything we do in here, these are pure functions. And they won't fail. So I'm going to start off with the filter films and just jump into here. So every time we do one of these transformations, right, we're using the dataset API. So we're defining, right, that this object is a data set and it's a data set of film. And just to be clear about it, right, this is where we're defining what our film is, right? I've just created this class and it has all these data types. And in cases where it can be null, we just say it's an option of that data type. And that will indicate that it can be null. If you don't do that and it is null, it will be a problem. So in this case, I was lucky enough to have a schema, so I could tell they had constraints. But that's usually something that's really fun to figure out in real life. So basically, right, we're just going to take this data set and we're going to follow and we're going to use a filter. And right here is where you start to see the difference between the dataset API and like a data frame or SQL API. Instead of referring to the column name and giving it greater than, we're going to refer to this this class member. So now we've like guaranteed that this thing exists and it's potentially a short integer. And then we're just going to match to see if it is something or if it is not. And right, we're trying to do filtering. So any type of filter function usually wants a Boolean output. So if there is a length, we're just going to check if it's greater than or equal to 90 minutes. If it is, then we'll get back true. If it's not, we'll get back false. If there is no time, we'll always be false because we're just going to exclude those in this case. I made that rule up when I was writing it. So this is like a very simple example, but basically, right, we take in a data set of films, we return a data set of films, and they will exclude ones that are shorter than 90 minutes. And now we're going to take a look at some of the testing. So there are many ways to write tests. This is just one. But like I said before, we can integrate Spark really easily. So created this little Spark function that just opens up a Spark context. Since we're in Scala, that's super easy to do. And I'm basically just going to go through, and right here started out that we're going to filter these films, and it should include films at greater than 90 minutes. And I can just come right in here and run this test. When I do that, I'm only going to run this one right now, but we're basically just going to take some films and we're going to do some Sparky stuff. We're going to take a sequence of films. In this case, I created a default film, which is just one of these classes with some default values in it so that I can kind of just have one object to work with. We can convert it to a data set and it'll already know the type because it knows that this is a film. And now it'll get a data set of films and then we'll pass the filtering. The response of this, right, will be another data set. And we can then collect that into a list and we should have one because I know in this case, if we looked at our default film, it's like 95 minutes or something. And let's see, did it run? Oh, it's still building. Yeah, okay. So basically we can do the same thing and again, go through more testing and I'm gonna copy my default film. Now I messed with something. I have all sorts of compiler warnings on. That was a bad move. So let's just do that again. So I'm gonna let that run in the background. And basically I'm gonna copy that object. I'm gonna set the length to 90 minutes. And now we're gonna guarantee that if it's 90 minutes, it's still included. And then we can copy it again and set it to done and copy it and test it, make it 0, make sure nothing gets output, do it again, make sure nothing gets output. And we can guarantee all the bounds of our conditions. And we can do that time and time again until the cows come home if we need to. And basically, I messed with some of my code up, I guess. So that's not fun. I'll fix that before I let it loose. So I just want to jump into a couple more things here, but I did annotate a lot of this. So, right, this is going to look pretty similar if you've done Spark before. But basically, we're going to just use a very similar or different type of join with almost the same conditions. And unfortunately, the dataset API is perfect. So we still have to do some text shenanigans that is susceptible to failure. But we can do unit testing really easily to make sure it always works. So in this case, we're going to do an inner join. And now when we do the inner join, we're going to specify and like this is just more for clarity that our output will end up being a tuple of both of the data sets. So we'll have just like 2 data sets combined together. And now if we want to look and do something row-wise across every record, we can do a map of that. And I'm essentially going to take a record and I'm going to create a new type. I'm going to take the left side film ID because I did this _1 and take the right side. And again, these are calling class members. So they're always like guaranteed to be there, which is nice. And then we're going to pass it on to another join. And in this case, I'm going to do a right join because we need outer joins in certain cases. And then just like when we saw with the data types on our classes, right? If it can be null or it can not exist, it'll be an option. So in this case, our tuple of output data is an optional film and an actor because we right joined films to actors. So we want to keep all the actors, but maybe not have all the films if the actor doesn't have any that were over 90 minutes. And then really just going to go and take a look at the final row here. And if there is no film, we're basically just going to create a record for the actor that has no films. And if there is one, then we're just going to add the actor's name. So yeah, this is a lot here to try to cover in like 15 minutes. But luckily I pre-computed it. and I compiled this right at the beginning of our meetup. So, so basically I went ahead and this is all set up, and I'll put more documentation on this, but I can go ahead and compile this and create a big jar. And that big jar is exactly what, like when I'm at Lark, we create these regularly, and that's what we send to EMR. And we add an EMR step with this jar that compiles in all of our required dependencies. And since we did all of our testing, we know exactly how it works. And it has all of our dependent libraries built in. So we just throw it at EMR and let it do its thing. And basically this will just run now. And it'll do all of our stuff, and it'll give us out that list of people. So yeah, that was very quick because I started paying attention to the time. But I'll add a little bit more notes in the code itself so that we can kind of clear up some of the gaps and figure out what I did before when I was messing around. But basically, so this is running through, and we've already queried some of this data. And it should just be a second. And this is all running on my MacBook. So we can do all this development. We can pass in fake data. And just to bring it all around, it can run the entire like main program as a unit test. And I can pass in default data. And this is something that we do all the time. It's great. And basically, sorry, just to really quick hit this. When we talk about these layers, this is going to look crazy because I just skipped right to it. But we did this read database. And what you haven't seen yet, I haven't gone into, is when this runs in a jar against our Spark in the terminal, it's running with a live layer. And we've defined that. And that's because we defined it here and we provided it in our main class. And this has, very much Spark read JDBC, just as you would expect to read out of a database. And that's how we're doing like our live runtime stuff. On the flip side of that, we have this testing stuff that's very similar. And it also has a read database function. But instead of calling JDBC, I just have a map of tables where a table name returns you back a data set that we create here. And then so when you do local testing, like we just looked at, we can pass in the map of the data that we want to be used. Boom, and that gets passed into our main function. And we can do row-wise comparisons of sets and have perfect unit tests and do some really fancy stuff. And trust me, it does actually work.
Live demos are hard, especially when you make code modifications.
Yeah, IntelliJ's been fighting me today. So yeah, I'll stop sharing for a bit, and we can talk about some questions and stuff.
Yeah, so happy to stay on for a bit longer. I know one question we had, when you are using Apache Spark, are you using it on-prem, in the cloud, at Databricks? I mean, you kind of gave it away a little bit.
Yeah, so at Lark, all of our development is actually done on our MacBooks. So I'm actually using a MacBook Air right now at home and running Spark with 2 cores, just enough to shuffle some data so we get real results. But even at Lark, like I use a MacBook Pro, and everyone on our team does all of our testing right there. And it's only after we pass all those tests and get it compiled that we send it up to EMR. And we actually do use Databricks. So that's a fun workflow. I actually use a lot of Databricks Scala to do that in our prod account against like real data and do a lot of discovery and be able to like test some transformations. Mm-hmm. Once I can like figure out the domain and like what we actually need to do, pull that into my Scala project, make some mock data, do all the testing, break down all the functions, and do the good software development stuff. So actually a little bit of everything.
using Databricks and AWS.
Yep.
Okay.
Yep. Databricks and AWS, EMR, and local. So full mixed bag.
How do you feel about, so this is the open discussion point. So if anyone wants to just kind of openly ask, feel free. I will cap it. We'll take maybe 1 or 2 more questions. But the next question is how do you feel about using multi-threading inside Spark?
Yeah, I guess that's a good one. I would probably try to steer away from it, right? The more you add multi-threading on, you're going to degrade performance from the program itself. Right, and then kind of you're putting your optimizations on multi-threading above the 1,000 developers that work on Spark for hundreds of lines, thousands of lines of code. So I would probably prefer to not use it, not do it, because like, Spark's going to parallelize it anyway. And especially when we're doing all that row-by stuff, right? And if we group them by whatever, like that's all going to get split up on the cluster anyway and like highly concurrent. So I would probably steer away from it unless I have a good use case, because those optimizations are going to be built in pretty good. And even like Java's, right, you're going to get some SIMD operations that they're going to do. So I would take advantage of their program as much as you can.
Yeah, no, I haven't even thought of doing like multi-threading with whenever I'm doing Spark stuff, because you could be fighting against the system almost.
Right. Essentially, like if you've heard of the noisy neighbors problem, right, in like AWS or something, where everyone has VMs on the same machine, you can kind of create that for yourself if you try to multi-thread within a little context.
Any other questions? Take 1 more. Any takers? Awesome. Oh, science models fit slowly. So most data science models fit slowly. How do you think of optimizing with Spark?
So yeah, I haven't actually done a whole lot of machine learning in Spark. Right. So if your data set's big enough, then it's going to be worth it, right? But with anything, if you try to right, once you distribute a small problem, you're going to create a lot more overhead. So yeah, if it is taking a while, it's possible, but I'd say it might depend on whether it's the data size or the feature space.
Yeah, and there are frameworks for optimizing training machine learning models. I don't think Spark is one of those top ones. If you're running into those issues, especially like deep learning networks, there are frameworks. I can't remember off the top of my head. It's been a while since I've looked into that space, but there are other technologies that you can use for, because you're not just, so with like MapReduce kind of computation, you're splitting the data up, you're doing aggregations, you're bringing it back together. Training a machine learning model, it's a bit more complex when you're trying to like create those distributions. So it's not as easy to just split everything up. But I do know that there are technologies out there if you're dealing with like model training problems to like speed that up and definitely parallelize it.
Right. So if you wanted to do more like multi-threading, like cross a cluster, like easily, right? So like if you're in Python, there's like Dask. That's a really popular one. Or even like celery workers, but.
Awesome. Well, that's time, everyone. Thank you for calling in. Thank you, Kevin, for speaking. Kevin, he'll post stuff, but I also like to send everything. I'll get everything from Kevin. I'll send out an email. I'll also post it to LinkedIn, post it to here, make sure that all the slides, all the code, all that stuff, recorded video. I'll be doing a little bit of editing and get that posted to YouTube in the next few days. Awesome. Thank you, everyone. Have a great night.
Cool. Yeah, if you guys want to talk about